Do first. Take the 16 over 3 and substitute it into g. So I'm going to take my g function. This is g. This is f. So take 16 over 3 and put it inside of g. So what I'm finding is g of 16/3, which means that would be 3 times 16/3 minus 1. Now, when you multiply something by the fraction, it just cancels out. So 3 times 16/3 is just 16. And 16 minus 1 is 15. Now I'm going to take that answer, which is 15, and put that into my f function. So find f of 15. So I'm just taking this 15, putting it here. So that would be the square root of 15 minus 6, which is the square root of 9, and my final answer is 3. So that is my answer to the first one. Do we have any questions about how we work through that? What y'all thinking? Okay, so now let's go to the bottom. I'm going to just go down and then go to this next column. So the first thing we have to do is find f of 10. So to find f of 10, I'm going to take 10, put it in your f function. So I'll give you a moment to get your answer. And whatever answer you get, you substitute that into your g function. So did we get 2? Who got 2? So I'm going to take that 2, plug it into g. G of 2. G of 2 is going to be 3 times 2 minus 1. 6 minus 1 is 5. So this here, let me make sure we all understand, this is my final answer. This is the final answer. The final answer is 5. Now, we could have did this a different way. We could have figured out what these two were and then substituted the number into what we came up with. But and you would get the same answer, and I really don't care which way you do. You do it the way you like. So what this is telling me to do is put G in F. So what I'm going to do is I'm going to rewrite my f function. And you see how the f function says take the square root of x minus 6. So I'm going to take the square root of, and then inside of that parentheses, I'm going to put g. Just like that. Now, there isn't anything that I need to multiply by. So the only thing I'm doing is combining my like terms, -1 and -6. And you're going to get the square root of 3x minus 7. That is what my function is. Actually, let me pull this over a little bit. So f, open circle g, of x equals the square root of 3x minus 7. So if I did this first, if I were to put 16/3, if I take this 16/3 and put it here, I'm still going to get 3. So there's 2 different ways you could do it. Because 16 minus 7 is 9 and the square root of 9 is 3. So the second one is saying put f in g. So my g function says 3, so let me write it not f, g open circle f of x. So g says 3 sometimes my little pen don't want to work. 3 times something minus 1. And then inside of that parentheses, I'm going to put the square root of x minus 6. So can I distribute 3 into the square root? What y'all think? Who says yes? Who says no? Right. And I can't subtract that. So this is actually my answer. I'm done. Like I'm hitting a wall. There isn't anything else I can do mathematically to that function. So you can leave it just like that. Or if you really wanted to, you could drop the parentheses and say it's 3 times the square root of x minus 6 minus 1. But I want you to understand that those are the exact same thing. So here or here. All right, any questions about example 7? All right, so now we're going to go on to example 8. I need to change that to say example 8. And we're going to talk about inverses. So what we're trying to do is show, this is how you show, let me rewrite that. How do we show that 2 functions are inverses? And I'll remind you in a moment what that means. So on the test or quiz, it's going to say prove that these 2 functions are inverses. And you have a choice. You can either do f of g of x. When you do this composition, you should get x. Or you can go g of f of x. So you only have to do one. You don't have to do both. But you have to show me how it simplifies down to x. All right, somebody left some shoes in here. It was over here somewhere. They're in the front. So just don't forget, yeah. So which one you want to do? F of G or G of F? We'll do them both for this one. For this person, we'll do them both. All right, so if I'm doing F of G, and again, you don't have to do both. You only have to do one. This means I'm putting G into F. So I'm going to take my f function, which is just a 3, and inside the 3, I'm going to put in 1/3 x. That's my g function. I literally took g and put it inside of f. And the only thing we need to do is simplify. When we multiply 3 times 1/3, what is 3 times 1/3? 1. So did we end up with an x? Yes. So I already know that they're inverses. But I just want to make sure you all understand. So I'm going to do the other one, but you only have to pick one. So I'm going to do the other one too. So my g function says 1/3 times something, and the something is 3x. This is my f function. And again, we get x.
So it's inverse if you get x.
You have to get x. If you get anything other than x, they're not inverses. So let's talk about what this means. And you don't have to write this next part down. I just need to give me a little bit more space. So if I were to create a table for f of x, okay. So f of x says 3x. So I'm just going to use the numbers 1, 2, 3. I'm going to multiply those numbers by 3 because that's what the function is telling me to do. It says take your x and multiply it by 3. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. What an inverse function says is that the g of x function, all of your y values are your x, and all of the x values are your y's. That's how we know they're inverses. So notice that these are the same and these are the same. That's the definition of an inverse. Your domain is your range, and your range is your domain. Oh, I'm sorry. I got it.
He just did his lesson in school. He just did his lesson in school. She throws some bullshit. Wait till she throws that bullshit in your face. He knows she's doing that.
Good to see you. All right. So let's go ahead and copy down this next one. Now, I also want to mention that I choose questions that look like your homework. So you're going to see, you only got 6 questions for the homework. These are models of your 2 questions. So this would be example 9, right? All right, go ahead and copy it down. So we're just proving, so we know that they're inverses, okay? But you have to show me that they're inverses. So that means you have to show me the algebra behind simplifying it to x. It has to make sense. So you just can't put one in the other one and say equal x. You got to show me the steps. How do you get there? That's why it says show. Because we already know that it's going to equal x. You have to show me. How do we get to x? So, again, you don't have to do both. But I'm going to do both because, you know, I'm teaching and stuff. So, I'm going to do this one. Which means put g into f. So, that's 5 minus 2 parentheses. And then inside of the parentheses, I have this. So this looks kind of a little tricky. So there's actually a couple different ways we can go about this. So how do you want to do it? We could distribute the 1/2, or we could just multiply these 2 and get rid of the 1/2. Okay. So if I multiply to get rid of the 1/2, it's not going to get rid of that minus. So I'm going to keep that minus there for now. But it will get rid of the 1/2, so I'll have 5 minus x. Okay, now what should I do? How do I get rid of the parentheses? What's the number that I need to multiply? Not 1, but -1. Let's distribute the -1. So that would be 5 minus 5 plus x. And then 5 minus 5 is 0, so you get x. So this is what I mean by show me. It has to make sense too. Because again, I know this is the answer. You need to show me you need to show how you get from here to here. All right, and I'm going to do the other one just because. But again, you don't have to when you're taking a quiz. You just got to do one, whichever one you want to. All right, so now I'm going to put the F inside of G. So G says 1/2, 5 minus, and then I have my x. And then inside of the parentheses, I'm going to put 5 minus 2x. So what do you think you're going to do first to simplify it? Distribute the negative. Good job. Go ahead and multiply this negative. So that's going to give me 1/2. I'm not going to drop my parentheses yet, though. So inside of the parentheses, I have 5 minus 5, and then that's going to become a plus 2x. So we're still working inside of my parentheses. All right, now what's going to go away? Oh, not quite. The 2 5s. So the next thing you should do is cancel out these 5, right? Do you agree that 5 minus 5 is 0?
Yes.
Okay. So now I'm down to 1/2 times 2x. And then I ended up with an x. So I don't know which one is easier. I don't know. Maybe the first one. I don't know. But again, you only have to choose one. All right, so we have finished everything that is on homework. What is it, 16? Remember, it's due on Monday. It's 6 questions. Just 6. All right, so now we're going to move on to 5-2. Well, maybe it was 5. I don't know. All right, so now we're moving on to 5.2. If you want to title your notes. This homework is due Tuesday. I know we got 3 homework assignments due next week. I'm trying to decide. There is one homework assignment after the quiz that we could do a worksheet that's a coloring page. Like you got to find the answers and you got to color the other side. Or I could stick with book questions. I don't know. I don't think you all would color.
I'll color.
You think so? All right. I'll think about it. Whenever I do in my other classes, they never color. Okay, so we all got the title down. Everybody got their 3 cutouts. So you're going to go ahead. We got 2. You're going to glue down all 3. So we need to glue down all 3. And then we'll talk about all 3. So yep, go ahead, glue down all three. And then after you get them glued down, can you please put your glue sticks back? I would appreciate it.
You're a grown ass man. No, just think about it.
I'll give him a look.
Just think about it. Just think about what just came out your mouth. It's on my leg though, so I'm gonna let it slide. I'm sorry. This is one time. This is one time.
Do this. I'll listen to that.
Chris is still up too.
I literally said it's probably doing you ready? All right.
All right, so we already talked about determining if it's a function. How do we know if it is a function? What can't repeat for it to be a function? X. But now we're moving on to one-to-one. Well, one-to-one, that's a special type of function. For it to be one-to-one, all of your Y values are different. That's what it means, unique. And all of your X values are unique, meaning there is no repeats. No repeats. In domain or range. That's what makes this one a little different. Now, when you're doing it, I would start off by doing a function test. If you see a repeat in X, it's automatically a no. You don't need to check Y. So, and this is our last, we just got to do these and then we're done. I'm going to have you write down the first question for Monday though. Okay, so I'm looking at my X's. These are my X's. Any of those the same? 2, 3, -3, 7. All right, now I'm going to check my Y's. 5, 7, 6, 4. All right, so this would be a yes. That's a yes. Now let's go to B. I have a 3, a 5, a 0, and a 6. Those are all different. But if you look at your range, do you see how we have these two 8s? 8 repeats, so that's why this is a no. It would be a function. Yes, it is a function, but it's not one-to-one. It's a function because all of my X values are different. But because I have a repeat in Y, it is not one-to-one. So I'm going to say no. And the reason why is because we have a repeat in the range. All right, let's look at C. Who says yes? Who says no? Why is it no? What is repeating? 4. The 4. So if this is a no, I don't need to check why. It's a no. The answer is no. No, because we have a repeat in the domain. And I don't know. I did make copies of the quiz, but I didn't really look at it. I'm assuming it normally will ask you to give a reason why though. So you do have to say a reason why. It'll be more room. You know, I just be trying to, be trying to make it. Okay, so let's look at the next one. Who says yes? I don't remember the answer. Is it a yes or a no? Who says yes? Who says no? Okay, why is it a no? What's repeating? The 2, yeah. So just know it's a no, and we got to repeat in range. And I'm not even going to write that for now. Just know the answer is no. All right, so now let's look at these function maps. I think these are kind of confusing because you're not used to seeing it this way. So what this map is saying, let's focus on this one here. Function E, or not function E, but E, says that I have an order pair. You see how this goes A to D? So that means AD, that's one order pair. And then BE is an order pair. And then CE is an order pair. So would this be 1-to-1? No, because what is repeating? Domain or range? The range. The easiest way to look at it is every value should only have one line connected to it. So if any of the values has more than one line connected to it, it's a no. So this is a no. F is a no because do you see how this A value, the letter A has 2 lines? Those 2 lines means that I have an order pair at AD and at AE. So that's a no. Hey. Ooh. You can sit here. Oh, sorry. Is somebody else knocking at the door? Oh. Hey, what you doing? Huh? You doing correction? Okay, 1 second. Just sit down. I'll be with you in a minute. Okay. So, where was I at? G. G. Do I have any repeats? See, every single value only has one line. So if I were to write G as a set of order pairs, it would be A, Q, because A connects, no it doesn't, it's A to R, I'm sorry. So it would be A, R, then my next one would be C to Q, and then the last one would be D to S. So do I have any repeats? So that would be a what? A yes. So this is a yes. And then lastly, H. H has a lot of repeats. If you zoom in here, A is every time there's a line coming out, if there's, see how this has 2 different lines? That means A is appearing twice. So we got A twice, we have B twice. Over here, we got P twice, Q twice, R. So there's just a lot of repeats. So that's a definite no. All right, last thing we're going to look at for today are your 3 graphs. So who remembers for it to be a function, what kind of test does it have to pass? Vertical line test. So now, for a graph, it has to pass the vertical line test and a horizontal line test. So it has to pass both. And I know looking up here, you may think that this is a vertical line, but we're actually going to graph this soon. These are all different values. They're just getting closer. They're just so small. The change is so small, it's hard to see it. But this is definitely 1-to-1. And then this rational is also 1-to-1. That's what we just finished graphing on chapter 4. So this would be a yes. This one is a yes. And then what does J fail? Horizontal or vertical line test? Horizontal. If I draw a horizontal line through that parabola, it crosses twice. So this is a no. And you would say because it fails horizontal line test. So don't pack up yet, because I do want you all to copy down our first question for Monday. And then we'll be done. I forgot the power went out. I got to reset my clock. Anybody need more time to copy this down? All right, so go ahead and copy this down for Monday. It's going back to what we were doing. So we're going to verify it, but then we also have to talk about the domain. So I'll give you a moment to copy that down, and then that is it for today.